Carl Summer, president of Reliable EDM, has a wealth of machining experience. Having worked as a machinist, tool and die maker, foreman, tool designer, and operations manager, Carl now shares with you from his wealth of experience.
Accuracy of EDM and heat expansion. One of the amazing features of the EDM process is the extreme accuracy that we can get with RAM and wire EDM. We can cut to accuracies of plus or minus 1/10 of a thousand. Let's take a look at this diagram. This is a diagram of a human hair. Average thickness of a human hair is 0.0025. That's 2.5 thousandths. Now, a tenth, you divide this hair into 25 parts to get 1/10. And this gives you the accuracy of wire and RAM EDM capable of machining plus or minus 1/10, one little section of a thousand. I'd like to demonstrate to you the thickness of a human hair. Many people think of a human hair as extremely accurate, but I'm going to demonstrate with this 10th indicator and this gauge block the thickness of a human hair. This is what we call a 10th indicator. Each line is 0.001, and this is 1 thousandths, this is 2 thousandths, and this is 2.5 thousandths. From here to here is the average thickness of a human hair. I have on this gauge block a human hair. This is a 10th indicator. I approach the hair. Approximately 2.5 thousandths. I go back again. The thickness of a human hair is approximately 2.5 thousandths. I worked for many years as a tool and die maker. I started out in a very sort of crude shop. Then I finally got into a shop where we did precision grinding. And I could grind parts within 1/10 of a thousand. So I understand what a tenth means. But a lot of people don't understand what 1/10 is. They put that down plus or minus 5/10 if its part is 3 inches, 10 inches, or even 18 inches. And I want to explain a little bit how important it is to understand what 1/10 is, or when you put down plus or minus 5/10. Let's just take a look at this piece over here. This is a flex element. We made thousands and thousands of these flex elements. And what they are, they're put between couplings. They mount a number of them together and allows a coupling to be flexible. Many years ago, we received an order for large flex elements. And they wanted their holes, the distance between the holes, like these two holes, to be within plus or minus 5/10 of a thousand. Now we can, as stated earlier, we can EDM with accuracy plus or minus 1/10 of a thousand. But the larger the distance, the more careful and the more skim cuts we have to do, and it gets to be more expensive. And it was rather interesting when I went to this place after we made their flex element. They went and they took a veneer gauge, and this is not for measuring tenths. If you're going to measure tenths, you should use a coordinate measuring machine like the one you're seeing on the screen right now, and not a veneer gauge. This is not meant to measure plus or minus 5/10, but they went there and they measured their holes like this here with it. Then they knew they didn't understand what it meant plus or minus 5/10. Now let's look at this chart over here, explain on heat expansion. Heat expansion. The coefficient of expansion of steel is 6.3 millionths. That's 0.000005063 per inch per degree Fahrenheit. If the temperature of a 10-inch piece of steel rises only 10 degrees Fahrenheit, it will expand 0.00063 of an inch, or a little over 6/10 of a thousand. If you had a part that measured 10 inches long, and it had to be within 5/10 of a thousand, and for somehow, if you just by handling it, it became 10 degrees warmer, it would expand to 6/10. It would be out of tolerance. And notice also, this is the coefficient of expansion of steel is 6.3 millionths per inch. Different metals have different expansion rates. I had an interesting experience happen to me many, many years ago in New York City when I was working in a machine shop also as a tool and die maker, and I was on a lathe and this piece was magnesium. It was a very hot day. I was using a boring bar and machining a hub similar to this, and I was boring out the cavity inside that had very tight tolerances. We sent the part after it's done. They take it back into a nice air-conditioned inspection room. And that's 68 degrees. Now, I machined that, when it was warm, we don't have air conditioning in New York City in the shops there. And what happened, it shrunk. Now, magnesium shrinks twice as much as steel. Fortunately, it got too small, so they returned the part to me, and I had to open it up again to make it within tolerances. This is a digital height gauge that we took from our inspection department, and we're going to show you what happens with heat expansion with that 4-inch gauge block, and there's a button that says air, and it puts air underneath so we can easily move this. And let's take a close look at what happens. I'm going to lower it down on the 4-inch gauge block and zero it out. Zero it out, raise it up. Now I'm going to take this gauge block away from here and I'm going to put it within my hands. I'm just using the warmth of my hands on this gauge block. Now I'm going to place this warmed up gauge block just from my hands and bring it down again. Expand it 3/10 of a thousand just from the heat of my hands. This gives you an example of heat expansion that you have to be careful when you handle gauge blocks. Just the warmth of your body will change the dimension of a gauge block. Let's look at this snowflake to see how accurate we can cut with wire EDM. This is a snowflake that we EDM'd, and it's made out of 2 pieces of tool steel. And I don't know if you can see the edge of it here, but I'm going to push it over to the edge and push it out. Slide over here. This gives you a little bit of an idea of the accuracy that we can do with wire EDM. And we can make this a press fit or a slip fit. And we're making this just so air can escape from the sides of that cut. As you can see, it goes right down. And give you another idea of it. We'll push it out again. There it is again, and we just go over here. And the escaping air just has it fall right flat down. Now I'm going to do one more thing. I'm going to take this snowflake and I'm going to twist it around. Now I'm going to turn it around, and if I carefully line it up, it has to be exactly lined up for it to work. You can see it goes right down. Bring it up again, and it will slide down just like before. Now you can see from the grain marks that it's in a different position. That's how accurate we can cut with wire EDM. I like to speak to tool designers and engineers, and that's concerning putting part accuracies on the parts that you're making. Some parts require tight tolerances, but if you can loosen them up a bit sometimes, it can reduce the cost of machining these parts.
Located in the heart of the high-tech energy capital of the world, Reliable has the largest EDM job shop capabilities in North America, specializing nationwide in wire, RAM, and small hole EDM. Our commitment to our customers and our passion for technology has made us the EDM specialists.